Hey everyone, welcome to Hub360 Embedded Sphere. In today's video, we are building a smart sensor control system using the ESP32 and a BMP180 sensor. With the help of the Blynk app, we'll be able to remotely control an LED and also monitor real-time temperature, pressure and altitude data, all coming from the BMP180 sensor. Before we dive into the project, let's quickly talk about what Blynk is. Blynk is a powerful Internet of Things IoT platform that allows you to build mobile apps to control and monitor hardware projects. It works with microcontrollers like the ESP32, Arduino and Raspberry Pi, and lets you connect them to the internet easily. With Blynk, you can create a custom dashboard using drag and drop widgets like buttons, sliders, and display to control device and view real-time sensor data right from your smartphone. Let's take a look at the components you will need for this project. ESP32, LED, a BMP180 sensor, jumper wires, a 220 ohm resistor. You can find the link to purchase all these components in the description box below. Let's begin by connecting the BMP180 sensor to the ESP32. Connect the GND pin of the BMP180 sensor to the GND pin of the ESP32. Connect VCC to 3.3 volts of the ESP32. There's also V in. Connect SDA to GPIO 21. Connect SCL to GPIO 22. Next, connect the LED to the ESP32. Connect the longer leg anode of the LED to GPIO 4 on the ESP32 through a 220 ohm resistor. Connect the other leg, the shorter leg cathode of the LED to ground. Now that we are done with the wiring, let's move on to create our Blynk project. Now that we are done with the wiring, let's move on to creating our Blynk project. I'll walk you through setting up your Blynk account, creating a device dashboard, data stream, and getting the auth token. Everything you need to connect your hardware to the Blynk IoT platform. Okay, step 1. Create a Blynk account. First, open your browser and go to blynk.cloud. Click on sign up and create a free account using your email. Once you are logged in, you will be taken to the Blynk dashboard. Create a new template. Click on templates in the left sidebar, then click new templates. Give your template a name like weather station or LED controller, depending on your project. For hardware, select ESP32 or whichever board you are using. Optionally, you can set a description and leave the connection type as Wi-Fi. Click Done to create the template. Here is a well-structured Step 3. Add data stream in Blynk. Now we will create the data stream. These are like variables that Blynk uses to either send data to your device or receive data from it. Inside your Blynk template, go to the data stream tab, click on new data stream and select virtual pin. Create 3 data streams with the following configuration: temperature, name, temperature, the virtual pin V0, data type float, maximum value 100 units Celsius. Then pressure, we have for pressure virtual pin V1, data type integer, maximum value 11,000, like 110,000 units PA. Then we have for altitude, we say name, altitude, virtual pin V2, data type integer, maximum value 9,000, and the unit meters. Once all 3 are configured, click create for each one. This data stream will allow your ESP to send real-time data from the Blynk, from the BMP180 sensor to the Blynk app, so you can monitor temperature, pressure, and altitude directly from your phone. For the LED, choose a digital pin instead of virtual. Under pin, select D4. This corresponds to digital pin 4 on your board. Name it something like LED. Leave everything else as default and click create. Step 4, create a web dashboard. Now let's design the dashboard that you will use to control the LED and monitor sensor data. Open web dashboard in your Blynk templates. Click on web dashboard. You'll find it as one of the tabs across the top. Add a switch widget for the LED. From the widget panel, drag and drop a switch onto the dashboard. Click the select to configure it. Under data stream, select your digital pin data stream, the one you created earlier for D4, e.g. LED pin _4. Optionally, change the label to LED. Then we are going to add gauge widget for temperature, humidity, and altitude. Repeat the following 3 times, once for each gauge. Drag a gauge widget onto the dashboard. Click on the gauge to configure it. Assign the appropriate virtual data stream. First gauge, temperature, virtual pin VO for example. Second gauge, humidity, V1. Third gauge, altitude, V2. Update the label for each gauge accordingly, e.g. temperature degrees Celsius, humidity, altitude. Set appropriate min-max values such as temperature 0 to 50, humidity 0 to 100, altitude 0 to 4,000 or higher depending on your application. Rearrange as needed. You can resize and move the widget around to fit your design. Place the switch at the top and arrange the gauge below it in a row or column. Once done, your dashboard is ready to control an LED and monitor real-time environmental data. Step 5, create a device. Now let's create a device using this template. Go to device in the sidebar and click new device. Choose from templates. Select the template you just created and click create. Once you create a device, a pop-up will appear in the top right corner of the screen. This pop-up contains 3 important pieces of information: Blynk template ID, Blynk template name, and Blynk auth token. Copy these values to your clipboard and save them somewhere safe. You will need to paste them into your code later to link your ESP32 to this specific Blynk project. You can also find this credential later by clicking on your device and selecting the device info tab. Now that our hardware and dashboard are all set up, let's walk through the code. Section 1, setup and libraries. we define our Blynk print serial. Yes, then this line allows us to print Blynk related debug information to the serial monitor. Super helpful if you need to troubleshoot your connection. Then we have Blynk template ID, Blynk template name, and Blynk auth token. Here we are including the credentials for our Blynk template and device. These are auto-generated when you create a new device in your Blynk dashboard. Please make sure you replace this with your own values, otherwise the device won't connect properly. Then the libraries included are Wi-Fi client, Blynk simple ESP32, Wi-Fi.h. Okay, included Wi-Fi.h twice. Adafruit's BMP180.h. These libraries do the heavy lifting for us. Wi-Fi.h and Wi-Fi client.h allow the ESP to connect to your Wi-Fi. Blynk simple ESP32.h handles communication between the ESP32 and Blynk servers. Wire.h allows communication with the BMP180 sensor using I2C. Adafruit's BMP085.h is the driver for the BMP180 sensor. Then we have where we created for the objects. We create a BMP180 object called BMP, and then we store our Wi-Fi name and password. We also define the pin connected to our LED. Here it's GPIO4. Ensure to change this to your own Wi-Fi name and password. With a variable to store sensor data, we have temperature, pressure, altitude. This will hold the values we get from the BMP180 sensor for temperature, pressure, and altitude. Then setting up timer, Blynk timer. Blynk timer allows us to perform actions repeatedly without blocking other parts of our code, like sending sensor data every few seconds. Then we have a function, send data to Blynk, which is in our void timer. This is the function that sends our data to the Blynk app. We are using virtual pins V0, V1, and V2. This should match the virtual pins you selected in your Blynk dashboard for temperature, pressure, and altitude respectively. The setup function, void setup serial.begin 9600. We start the serial monitor so we can read debug messages. If not bmp.begin. Here we initialize the BMP180 sensor. If it's not connected properly, we show an error and stop everything with an infinite loop. Blynk.begin, Blynk auth token, SSID, and pass. This connects the ESP32 to Wi-Fi and then links it to your Blynk account using the auth token. Then we have our timer.setInterval 400L, my timer. This tells the timer to run my timer every 4 seconds. So you get fresh readings on your app every few seconds. Then we also have pin mode, LED output, digital write, LED low. Finally, we set our LED pin as an output and make sure it starts off. The loop function, every time the loop runs, which is constant, we read the latest sensor data and store it in our variables. We have blink.run and timer.run. Blink.run is required to maintain communication between your ESP32 and Blynk servers. Timer.run ensures our my timer function keeps working in the background. Okay, I'm done. And that's it. You've successfully built your own remote monitoring and control system. And that's it. You've successfully built your own remote monitoring and control system using the ESP32, a Blynk dashboard, and just a few components. With real-time readings from sensors like the BMP180, you can remotely monitor temperature, humidity, and altitude. right from your web or mobile dashboard. Plus, with just a tap on your screen, you can control an LED connected to the ESP32, making this a powerful combo of IoT monitoring and remote device control. You can find all the components used in this project along with the link to the Hub360 website, where you can purchase them, in the description box below. The complete code and freezing circuit diagram are also available there to guide you step by step. If you found this project helpful, don't forget to like this video, subscribe to the channel and hit the bell icon so you don't miss out on future builds. Thanks for watching and see you in the next one.